In this video, we're going to look at how to represent the symbols for nuclides of various isotopes. Let's do a little bit of review. We've seen that the atomic number is represented by the letter Z and represents the number of protons that are in the nucleus. We've also seen that A represents the mass number, which is the total number of protons and neutrons in the nucleus. We're going to use the symbol X here to represent the element symbols that we would use off the periodic table. Different isotopes have different mass numbers, and for that reason we need to identify via that mass number what the different isotopes are. To the upper left corner we would put the mass number to represent how many protons and neutrons. To the lower left we could also put the atomic number. As an example, let's look at the three different isotopes for carbon that occur naturally. We have the element symbol. To the upper left we would put the 12 for the isotope carbon-12. And to the lower left we would put the atomic number 6, since carbon has 6 protons. Now the 12 represents that this isotope of carbon has 12 total protons and neutrons. Since we have 6 protons, we know that this isotope has 6 neutrons as well. In carbon-13 and carbon-14, we see that we have the same number of protons, 6, but we now are differing the mass number, which means we have different numbers of neutrons, and this is what makes each of these nuclides an isotope. They are all carbon, they all have 6 protons, but they'd have different numbers of neutrons. Carbon-13 has 6 protons with 7 neutrons, and carbon-14 has 6 protons with 8 neutrons. Now, representing the atomic number in the lower left is somewhat redundant. So most of the time, you will see element symbols simply written with the mass number to the upper left without the atomic number to the lower left. This is because we already know it's carbon. Another way that we can represent these, and you'll find this a lot of times in text, or you may see it on the internet, is carbon with the isotope value to the right, but the number that's written to the right would represent the mass number. Sometimes you would have the element name actually written out with that mass number next to it as well. We've looked at how we can represent changes or different isotopes with varying numbers of neutrons, but we can also have situations where we can have different numbers of electrons. Now, a neutral atom is an atom where the number of electrons and the number of protons are going to be equal. Because electrons and protons have equal but opposite charge, the same number of electrons and protons would cancel the charges out to equal 0. An ion is an atom that has gained or lost an electron. An atom that gains electrons is going to be negative. The negative value that it's going to have will equal how many electrons it has gained. So if an atom has gained 3 electrons to form a negative ion, that charge would be 3 negative. Atoms that lose electrons are going to be positive. And again, the positive value will equal how many electrons have been lost. If you've lost 3 electrons, then it's going to be a 3+. If you've lost 1 electron, it's going to be a 1+. The symbol, or how we would represent this, is we would have the element symbol represented here by the X again, and to the upper right we would put the charge. We would put the number, the numerical value for how many electrons have been lost or gained, and we would put the positive or negative sign next to that. An example would be oxygen with a 2- charge. In this case, the oxygen normally has 8 protons and 8 electrons. In this ion that has gained 2 electrons more than what it normally would, the total number of electrons is going to be 10. The number of protons is still staying the same. It has 8. Because it has 10 electrons, which is 2 more than 8, it's going to have a 2 negative charge. With magnesium, that is a 2+ ion. This is an atom that has lost 2 electrons. We now have in magnesium 12 electrons. Normally it has 12 electrons. So with magnesium, if it has a +2 charge, that means it has lost 2 electrons, so this magnesium ion would only have a total of 10 electrons. 10 electrons versus the 12 protons, because again, the protons have not changed here, it's the number of electrons that has changed. So if we have 10 electrons, that's 2 less than the number of protons, so we have more positive charge by 2. Another example would be the fluoride ion. Fluorine has 9 electrons and 9 protons. In this case, because it is a -1, it is going to have 10 electrons, and that extra electron will give it a 1 negative. Now, because it's only a 1, we can drop the numerical value of 1 and just represent that by the symbol of the negative sign. So it's an understood 1 negative here. So this fluorine has 9 protons and 10 electrons. Potassium has 19 electrons normally. It has 19 protons. Because it has a +1, this means it has lost an electron. We are then going to have 18 electrons and 19 protons, giving it that extra positive charge. Now let's look at how we can use these values, these numerical values, to identify how many protons, neutrons, and electrons are in an atom. In oxygen-17 isotope that has formed a 2 negative ion, we have 8 protons. We know this because the oxygen is atomic number 8 on the periodic table, and the atomic number tells us the number of protons. We have 8 electrons when it's neutral. In this case, since it's a 2 negative, we've added 2 electrons, so that's going to give us a total of 10 electrons. Mass number is equal to the protons plus the number of neutrons, or we can symbolize this as A, mass number, is equal to Z, the atomic number, plus the number of neutrons. If we plug our values in, we know that we have a mass number of 17 based on the symbol. We have 8 protons because atomic number 8 is for oxygen. So our unknown here is our neutrons. And when we do the math, we find that there are 9 neutrons. So in this ion, which is an oxygen-17 isotope, we have 8 protons, we have 9 neutrons, and we have 10 electrons. Let's look at 3 more examples. Magnesium-26 is going to have a 2+ ion. We have 12 protons because magnesium is number 12 on the periodic table. We have 12 electrons normally, but because it is a 2+, we have lost 2 electrons. So we have 10 electrons in this ion. Our atomic number and mass number can give us the information that we need to find the number of neutrons. So the mass number is 26. That's going to equal 12, which is the atomic number, plus the number of neutrons. And when we do that math, we see that there is going to be 14 neutrons. So our magnesium-26 ion that has a 2+ charge is going to have 12 protons, 10 electrons, and 14 neutrons. Our fluoride ion, which is going to come from the fluorine-19 isotope, is going to start off with 9 protons because fluorine is element 9 on the periodic table. We have 9 electrons normally. Because it is a -1, we have added 1 electron. So that's going to give us 10 electrons total. Our mass number is 19. The atomic number is 9. So that will give us a total number of neutrons of 10. So our fluoride ion made of the fluorine-19 isotope is going to have 9 protons, 10 electrons, and 10 neutrons. Our last example is going to be potassium-40. We know that potassium is number 19 on the periodic table, so it's going to have 19 protons. We have 19 electrons then. Since it is a 1+ charge, we are going to be subtracting 1 electron. So that's going to give us 18 electrons total. Our mass number is 40. That's going to equal the atomic number plus the number of neutrons, the atomic number being 19. And that gives us 21 neutrons. So our potassium-40 ion is going to be 19 protons. It's going to have 18 electrons and 21 neutrons. So the math, the basic idea of how to determine how many protons, neutrons, and electrons is relatively straightforward if you're given the information that you require.